Hello everybody, in this video lecture we will cover regions of the epiphyseal plate, or we call it growth plate, and we will have some histology slides here to look at. So bones can grow, when bones grow they can increase in the diameter. So over here you can see how bone became wider. We go from infant to adult. And when bones grow in diameter, we call it appositional bone growth. So here's the word, appositional. And what happened over here, actually we have this membrane, and this membrane is called periosteum. And you know that inside the periosteum, we have osteoclast and we have osteoblast. And this is osteoblast cells, they can secrete bony matrix, and they're gonna deposit it in the layers called circumferential lamellae, right? So they're pretty much kind of like depositing these new layers of matrix, and bone became bigger in the diameter. At the same time, osteoclast gonna resorb bone from inside. So we increase both medullary cavity and diameter of a bone. That's appositional bone growth, and the bone grow wider, increase the diameter, and growth happen on the surface, right, at the periosteum level, But bones can also get longer. So over here you see the bones getting longer, and we call it interstitial bone growth. And actually it's not real a bone growth, even bone became longer, but the growth happened inside this blue line over here, and this is cartilage. That's not a bone. This is called cartilage growth plate or epiphyseal plate, because this part of the bone is called epiphysis. That's why this is our epiphyseal plate or growth plate. Right, so and if you look at this X-ray of a young adult, we know this is a young, well, maybe not, maybe even a child. So that's obviously the person, his or her bones are still growing, and this is adult. And we would know it because look over here. Is this line? Actually, this arrow shows to this. Look like almost there is a fracture inside the bone, but that's not a fracture, it's just a cartilage, and cartilage appears darker on the X-ray. And in this picture you don't see the plate anymore, it's closed growth plate, so what is left is just a line. And if we only have a line, we know that this bone cannot grow longer anymore. So when we look at this epiphyseal plate, so it's located in the epiphysis, right? And it can be divided into several zones. In some books, they start with the proliferation zone. In other books, they're gonna start with the resting zone. But your book divided into proliferation zone, Hypertrophic zone, Calcification zone, and Ossification zone. And just on the surface over here, we have a resting zone. So resting zone, we have small inactive cartilage cells inside the lacunae, chondrocytes, right? And then in the proliferation zone, we have chondroblast, right? And these chondroblast cells, they start dividing. So they're dividing and they form this like a columns of the lacunae, right? Chondroblast quickly divide and pushes the epiphysis away from the diaphysis, because that's epiphysis, and over there would be diaphysis. And that's what makes bone longer. In hypertrophic zone, all the chondrocytes enlarge and signals the surrounding matrix to calcify. So chondroblast over here stop dividing, right? So here we had chondroblast. Now they stopped dividing and became chondrocytes, and they increase in size. So now you see like big cells, and lacunae also getting larger. And then they start secreting minerals, right? Calcium. So they start depositing calcium in extracellular matrix, and this is where we have calcification. So matrix became calcified, and because it's became really like rigid, it's not easy for nutrients and oxygen diffuse through this hard matrix. That's why chondrocytes die. And what they leave behind is trabecular shape calcified cartilage that is not a bone yet. Now cartilage is dead here, right? These chondrocytes are dead. Now at the same time, in this zone, we have formation of new blood vessels. So blood vessels entering this area, and blood always brings nutrients, it brings oxygen, but what else blood brings are actually osteoblast and osteoclast. Now osteoclast gonna digest this calcified cartilage. So here's our osteoclast, right? So yeah, doesn't show it much. So osteoclast is gonna pretty much digest this cartilage, and osteoblast starts secreting osteoid. So that starts secreting the bone tissue, and calcified cartilage is replaced by actual bone tissue in the shape of this calcified cartilage. So we're forming new trabeculae of the spongy bone. Now the next 5 slides that we have, you will see histological slides of the epiphyseal plate. Right, so you can see this is magnification of 40x, and we move over here, that is 100x. So you can see resting cartilage would be right here, right? So that's a resting cartilage. And then when you start seeing this column, right, there's long columns here, or here, or here, right? That's a proliferating zone. So chondrocytes divide. Now they became larger here. Hypertrophic zone, right? And then zone of calcification it's not very thick, so probably somewhere in this area, right? That will we have calcification, and this area over here is ossification. So that was 100 magnification. This is also the same magnification, but here we have 400, and this proliferation zone, and you know it because you see these columns, right? And those are lacunae with a chondroblast inside. So here, so that's proliferation zone. So for your exam, if you see the slides, you need to identify what zone of epiphyseal plate is that. This is 400 for calcification and hypertrophic zone. And again, it's really kind of hard to tell exactly where we have this hypertrophy and where we have calcification. That's why these zones, you know, kind of like will come together on your exam. But you see, that's our column, so that's still proliferation. But over here, when cells became larger, and it seems like here it's even empty cells, right? So that would be a calcification zone. And the last slide will show us ossification. So here's ossification, and we see this newly formed trabeculae of the spongy bone. Right, so that's it for this presentation, and hope it was helpful.